Today I'll be explaining to you what is selection sort. But before that, let me introduce to you the members first. And the members are Saidamin Alamada, which is me, Kimberly Babaran, and Angela Uning. You may ask, what is selection sort? Selection sort is a straightforward sorting algorithm that operates by breaking an array into two parts, the sorted on the left and the unsorted section on the right. The algorithm iteratively identifies the minimum or the maximum element from the unsorted part and swaps it with the leftmost element in the unsorted section. This process repeats until the entire array is sorted. The algorithm's efficiency is characterized by its complexity, which is O open and close parentheses n caret 2. In the worst case, where n represents the number of elements in the array. Consequently, it may not be the most efficient choice for sorting large datasets when compared to more advanced sorting algorithms like quicksort or merge sort. However, its simplicity and ease of implementation make it suitable for datasets or uh, as a teaching tool to illustrate sorting principles. Here are 5 steps to remember in selection sort: initialization, finding the minimum, swapping, iteration, and completion.
The provided code is an implementation of the selection sort algorithm in pseudocode. Selection sort is a simple comparison-based sorting algorithm that works by repeatedly selecting the minimum element from the unsorted portion of the array and moving it to the beginning sorted portion of the array. Here's a step-by-step breakdown of the code. Selection sort, open parenthesis, data, square bracket, and close parenthesis. For I equals 0 to data.length minus 2. Select the smallest element among data, square bracket I. Data, open parenthesis, data.length minus 1 and close parenthesis and semicolon. Find the index of the minimum element. Swap it with data square bracket I semicolon. Swap the minimum element with the element at position. So let's break down the algorithm step by step. Step 1. The outer loop. For I equals 0 to data.length minus 2, iterates through the array from the first element, open parenthesis, index 0 and close parenthesis, to the second to last element. This is because after sorting the first n minus 1 elements, the last elements is already in its correct position. So step 2. Inside the loop, we need to find the index of the smallest elements among the unsorted portion of the array, which starts at index I and extend to the end of the array. Open parenthesis data.length minus 1 and close. We then swap the element of the current index I with the smallest element found in the unsorted portion. This operation effectively moves the smallest unsorted element to its correct position on the sorted portion of the array. So let's proceed to step 4. The loop continues and in each iteration it finds and places the next smallest elements in its proper position. Step 5. After the loop completes, the entire array is sorted in ascending orders. The last step, step 6. Selection sort is not the most efficient sorting algorithm for large datasets, as it has a time complexity of 0 and the worst case, where n is the number of elements in the array. However, it is easy to understand and implement, and it performs well for small datasets or when a sample sorting algorithm. The provided code is an implementation of the selection sort algorithm in Java. Selection sort is a sample sorting algorithm that repeatedly selects the smallest or largest depending on the sorting order elements from the unsorted portion of the array and moves it to its correct position in the sorted portion.
So hi guys, so first thing we're going to do is implementation of the selection sort algorithm. So I'm going to share my screen. So this is I'm going to type INJ Alice. Sorry. Then go here. Given C for I equals 0 and I less than data length minus 1 I plus so the selection sort method takes an array of objects as input and sort it in place three integers variables I, J, and list are declared. These variables will be used in the sorting process. So the outer loop controlled by I iterates from 0 to data length minus 2. It means the loop will run through all elements except the last one. The purpose of this loop is to divide the array into a sorted portion from beginning to I and unsorted portion from I to the end. So we continue. So here, as you can see, you can find the index of the smallest element in the unsorted portion. So 4G equals I plus 1 and least equals I and J less than data length 3 plus 2. So the inside the outer loop, there is an inner loop controlled by G. This loop starts from I plus 1 because elements in the sorted portion are already in the correct position, so we're looking for the smallest element in the unsorted portion. So the the least variable is used to keep track of the index of the car smallest element in the unsorted portion, so it is initialized to I. And within the inner loop, the code compares the element of index G with the element of the current list index. It does this by first step testing both elements of comparable and then using the compare to method, if the element of index G is smaller than the element of the less index, it updates the list variables. So, as you can see, 4 equals I plus I 1 list equals I G U. So, if data if, if data if nested expression comparable data J compared to data please so less than 0 is GS. After the inner loop completes, please will contain the index of the smallest element in the assorted portions of the array. So we're going to type the comment. Type the comment. So the comment if the index of the smallest element is equal to the current index and so space. And we're going to type the code here. As you can see, swap the elements of those positions. Like if I equals this, then swap data with I so here, finally, after the final index of the smallest element, the code checks if I the current index and the outer loop is different from least the index of the smallest element. If they are different, it means the smaller element was found as an unsorted portion, so it swapped the elements of position and I analysis. So this places the smallest element in its square's position in the unsorted portion. Overall, this process continues until the inter-array is sorted in ascending order. The swap function is assumed to be defined elsewhere in the code and is responsible for exchanging exchanging elements the at two given position in the array.
So that will be all. I hope you understand something what is selection sort. So I hope you have a nice day and God bless to all. Thank you for listening. Bye.